Now let's look at some compression utilities that are commonly found on NIX-based systems, with Red Hat Enterprise being no exception. So we'll label this section Compression Utilities. And there are a number of them, but of course, as the name implies, compression utilities feature compression of content, which means the converse as well, so compression, decompression. And as a consequence, you're able to move content across the network, primarily the internet, where bandwidth is usually a constraint or a concern, in as nifty a fashion as possible. So you can reduce larger content to a much smaller footprint for transport. You may also do so just for storage reasons. Red Hat Enterprise Linux 6 supports the compression file system, the Fuse compression file system, which allows users to auto-create compressed files on the fly. Now, there are a number of key tools that are included, including but not limited to gzip, which also includes its counterpart gunzip, so gzip/gunzip, which we'll look at first, bzip2, and its counterpart bunzip2, and traditional zip unzip. There's also compress, but gzip and zip support the compress format, so we won't be looking at compress. In addition, it's often quite common that you find content in a tarred image. So tar is another utility that we'll look at. It's a means of rolling a number of files and or directories into one file for easy transport. So oftentimes when you find content for NIX-based systems, it's both tarred and gzipped, or tarred and bzip2'd or zipped. So tasks include work with gzip as the first task. So we need some content that we'd like to compress. Now we've created a file, 1million.txt. It's only 6.6 megabytes, so nothing to fuss over. However, it still could benefit from some level of compression. It's roughly 6.6 megabytes. Its exact byte size is 688, 8896, or an additional 896. So how do we reduce this? Well, one way is to use gzip with the compress option, or the C option. Both gzip and bzip2 support similar options. So gzip with the compress option takes the source file or files as input on standard in, so 1million.txt for example, but it sends the compressed output to the standard output location, which is standard out. So redirects compressed file to stdout, which is generally not desirable unless you're using piping to move the content from gzip into a program that understands gzip format. But let's show you what happens when we execute gzip in this form, instructing it to compress the input file 1million.txt. So notice on standard out is the gibberish that correlates to the binary that represents our file. And that's the whole thing. Now sometimes it corrupts the console. One way to work around that is to type reset. Our console currently is not corrupted. If we clear screen, it'll reset, but reset will do that for us, and a which reset shows it's in user bin. So it's a way of resetting your terminal, which happens to be sudo terminal 1 for us. Now by running gzip with the compress option without redirecting to a file, the compressed file was not saved. The entire output was dumped to the screen, which is of no use to us. So to alter this command and to preserve the compressed file, we'll run gzip with the compress option and use output redirection, which we've discussed, to 1million.txt.gz. This creates or redirects output to the file. So redirects compressed output to file named 1million.txt.gz. and then that file will be considerably smaller and more suitable for transport across slow wide area network connections, such as DSL and otherwise. Now we'll add our command chaining logical ending to ensure that after it's completed, if successful, that it echoes the exit status. And if all looks well at the end of the process, then we know we can trust the file. So the exit status is clean. Let's LSLTR. And let's compare and contrast the two files in terms of size. Well, human readable 1 million star, and notice that one is a third roughly of the other, actually slightly under of the other. So we've achieved a roughly 1/3 compression ratio, or 3 to 1. So for every 3 bits, it's been reduced to 1 roughly. So this is the size of the 1million.txt.gz. And the larger you go with the source file, the better the compression ratio generally for textual content. So we've achieved compression. This is much more suitable for email or for other applications that require the usage of the wide area network, such as DSL cable, etc., T1 lease lines, and so on. So that's using output redirection, and it generates it. Now, you can list or enumerate the contents of a file by using the L option. So let's just show you what we mean by that. gzip L 1 million text GZ returns to standard out the file that's contained within the compress file, including its compressed footprint, roughly 2 megs, and its uncompressed footprint, roughly 6.5 megs, and also including the ratio, which is better than 2/3 for this particular file. So -L provides us with statistics. So gzip L 1 million text .gz returns compression statistics, which can be useful for you to determine whether or not you've achieved a good ratio. But you can eyeball it looking at the byte size to determine that. Now, another counterpart to gzip that understands gzip compression is zcat. Zcat is useful when you need to concatenate the contents of files that have been gzipped, such as log files in var log. Zcat understands gzip compression. So zcat 1 million.txt.gz dumps or cats or catenates or concatenates, they're all the same, the contents of 1 million.txt.gz to the default location of standard out. So it's a way of decompressing on the fly the contents of the zip file. Now in our case, 1 million.txt.gz is a text file, so zcatting it would work. For other content, such as binary content, it would work, but it would generate a lot of gibberish in your terminal window. Let's reset the buffer. Another thing about reset is that it clears the buffer. Notice our scroll buffer has been reset, so there's no ability to reference any older content. So let's try to zcat, and you're going to see a dump of 1 through 1 million to stand it out. So this is in fact decompressing on the fly, and it allows us to see the content or even redirect it to a file as you could with gunzip, which leads us to gunzip. So while that decompresses, let's introduce gzip's counterpart, which is gunzip. Gunzip followed by the name of the file will do the trick. .gz. So this will decompress it. Or you could use gzip-d. Let's see what happens when we decompress the gz file. So this is extracted all the way out to the last value, and that's gunzip 1 million. Now it asks us if we'd like to overwrite the source file. If you indicate yes, then it overwrites it, and note that it removes the .gz compress file. So gunzip will attempt to overwrite the existing file with your permission, of course. gunzip-help will give you additional information. You can gunzip, decompress, send it to standard out, or send it to a different file, for example. So let's go through our history and get an instance of gzip. We'll rerun the creation of 1million.txt.gz. By the way, another feature of the shell is the ability to access previously executed commands from the command history using the number preceding the command. So in the case of the command that's of interest to us, its number is 235. So exclamation 235 will run that command. This will recreate the file for us. And now we've got the GZ file, that is. And if we unzip it, sending the output to, let's say, 1million.txt2, for example, for a new file, and it asks us to overwrite the original file because we didn't use the C option. Let's try it again. So gunzip, and that's going to be sending it to standard out and then into 1million.txt2. And let's take a look as to what's been created. And there's the new file, which is identical to the original file. So gunzip, the original invocation, overwrites with permission the original file, which is labeled without the GZ suffix, whereas gunzip with the C option sends the output to standard out. And we can take advantage of output redirection to send the contents to a file, as we did 1million.txt or text2, that is, using output redirection. So this is a way to redirect the content to a different file in the event that you'd like to preserve the source file. But logically, if you compress a file or gzip it, you will want to remove the original file to save space. So gzip, gunzip, zcat, just consult either with the help option to see some of the useful options as mentioned. Gunzip with the help option returns the possibilities, including, for example, the C option to send to standard out, the D option to decompress. Gunzip is just a special invocation of gzip with the D option. So it's all the same command. If you do a which gunzip, for example, and if you do an ls of that, gunzip, we see its location. Let's take a look at its inode, and let's take a look also at bin gzip, and we see its link, and let's take a look at the inode as well. Different inodes, but notice that gunzip is only 61 bytes. This tells a story. It tells us that it's really just a special invocation of gzip. So that's a little bit about gzip. Now there's still two other useful compression tools. Again, oftentimes on the net you'll see files that resemble the following. So note, typical compressed file online resembles, for example, file name .tar.gz, which means it's a tarball archive that happens to be compressed. Now let's look at the other tool, bzip2, which offers usually better compression than gzip, but nonetheless you'll see either or on the net. Perhaps gzip compression is more ubiquitous. So the commands are similar. To create content, bzip2, create 1million.txt, sending the output to 1million.txt.bz2 as the conventional suffix is. Now, of course, if you neglect to specify output redirection, just like with gzip, the content is sent to standard out. Let's try it, for example. And notice bzip complains that it doesn't want to write to a terminal because it knows that it's compressed data, whereas gzip does not. Now let's write to a file. And if that has run successfully, let's lsl 1million star. and compare and contrast. Now note that the 1million.txt.bz2 file is roughly half the size of the GZ counterpart. Let's turn on human readable. Notice again that the options for ls surround the file name. This isn't necessary, but it's convenient that ls understands options both before and after the files that are to be interrogated. So let's take a look. Notice 1.2 versus 2.1. Big difference when considering moving this file across the internet, perhaps using email. So for this particular file of textual data, bzip has made a significant difference, an almost 50% differential. So bzip2 will compress and bunzip2 will decompress. So bunzip2 1million.txt.bz2 or bzip2 with the D option to decompress. Either or will decompress. Again, you don't have to memorize any of these options. Just run bzip2 with the help option, and you'll see D for decompress, for example. There are even various levels of compression that you may attempt to achieve, depending on how much time you've got. The best compression, which is -9, takes a longer time to achieve than the fastest compression, which is -1 or -- fast. Either or will do. So let's go ahead and take a look. Notice the various options that are available for bzip2. So let's bunzip and see what happens when we attempt to dump